Hello everyone. In this video, I'm going to be discussing on PYQ questions on thin lens. Alright, so let's look at the question quite quickly. Alright, I have a biconvex glass lens of radii 35 centimeters. So I know my values of R1 is equal to negative R2, which is 35 centimeters. Then of course my R2 is just negative 35 centimeters, and I know this because if I were to draw a biconvex lens, biconvex means that if I look at from the front, it is a convex lens, and then if I look at from the back, it is also a convex lens. Alright, so if my incident ray is from the left incident ray, right, I have the first surface R1 to have its radius center point behind the lens, and then I will have the radius or center of curvature of the second surface in front of the lens, R2. So just from that picture alone, I can know that one of the values is going to have is going to be positive and the other value is going to be negative. Okay, and then the other information that is provided in the question is that the refractive index of chloroform is 1.44 and the refractive index of glass is 1.57. Now another key word in the question is that its focal length is doubled when it is placed in an unknown liquid. Okay, so the focal length in chloroform is doubled. That means 2 times the focal length in chloroform is equals to the focal length in unknown liquid. Having a bit of a foresight, what I'm going to do is I'm going to take the inverse of both of this. That means that I will have 1 over FUL is equals to 1 over 2 FC. Okay, so that whatever I calculate for FC, I can just take half of it. Okay, so let us first write down what's the equation for FC then. FC is in fact 1 over FC equal to Ng over N chloroform minus 1, and then 1 over R1 minus 1 over R2. I can cast R1, which is equals to negative R2, as just R. Okay, and what I'm left with is 1 over FC equal to Ng over Nc minus 1. Then I will have 1 over R minus 1 over negative R, right? And what I have now is going to be Ng over Nc minus 1, and then 1 over 2 over R. Okay, now if I were to find 1 over FUL, all I need to do is take half of this 1 over FC. So that means I will have half times 1.57 over 1.44 minus 1. Then I have 2 over R. And that R, I can substitute the values at this point, is 35 centimeters. I can cancel out the 2's, and I'm left with 1 over FUL is equals to 13 over 5040, and I take the inverse of that. I will find that my FUL, the focal length of the lens in the liquid, is equal to 387.7 centimeters approximately. Okay, so that is the solution for the first question. Let us now proceed to the second question. Okay, now we are on the second question. Again, we have a biconvex lens with surfaces of radii of curvature of 18 centimeters and 20 centimeters. So that means I'm going to have r is equals to either negative 18, sorry, r is either positive 20 comma negative 18, right, cm, or I have r equals to 18 comma negative 20. Either way, it doesn't matter because it's going to just add up anyway, and in fact I can show that it is going to be the same in both cases. I will have, let me just write down that, in both cases I will have 1 over 20 minus 1 over negative 18, which is equals to 1 over 20 plus 1 over 18, right? If I have it the other way around, I have 1 over 18 minus 1 over negative 20. This also results in 1 over 18 plus 1 over 20. So it doesn't matter which one is chosen, right? So either way, both answers, both will result in 19 over 180. So both are going to equal to so 1 over 18 plus 1 over 20 is 19 over 180. Okay. Yep. All right. So now we want to look for the focal length. All right. The next information given is that the object is placed 24 centimeters in front of the lens. So that means my u is 24, positive 24 in fact, and a real image meaning that it's going to be positive. I'm just going to write down there real image. So that means it's going to be v is bigger than 0. That means my v is going to be positive 32 centimeters. Okay, I need to find the focal length, so I can quite easily use the thin lens equation. I will have 1 over f equals to 1 over u plus 1 over v, and this is going to be 1 over 24, so positive 24 plus 1 over positive 32, and that would lead me to have my f to be 13.71 centimeters. That is the answer for the first part, which is the focal length. Okay. And then now I have to look for the refractive index. Because it doesn't say in the question if this lens is put in any liquid, we can assume that this is in air. So lens in air, right? So that means the refractive index of the medium is going to be equal to 1. Okay, so then I have 1 over f equals to n, and then glass, n of the material of the glass of the lens, the refractive index of the lens over and medium minus 1, then times 1 over 20, sorry, 1 over r1 minus 1 over r2. We've established that 1 over r1 minus 1 over r1 minus 1 over r2 is 19 over 180. So that means I can substitute f for 13.71. N of lens is what I'm looking for. N of medium is 1 minus 1, and I have 19 over 180. This would lead me to find that the refractive index of the lens is in fact 1.69, and that is my final answer for the second part, which is the refractive index of the lens. Okay, so now let's proceed to the third question. Okay, so this is the third question. on thin lenses. Let's just read the question. It says that a converging meniscus lens is made from a glass of refractive index 1.52 having a radius of 7 centimeters and 4 centimeters. An object is placed 24 centimeters in front of the lens. Calculate the position of the image from the lens. Is the image magnified or diminished in size? Justify your answer. Okay, first things first. If you have a converging lens, that's a bit too big. Let me change that. If I have a converging lens, I know my f is going to be positive, right? Because it converges. It converges. That means the real line, the real ray line, is going to converge behind the lens, right? So if I were to have f to be positive, my 1 over r1 minus 1 over r2 must be positive. That means the only possible combination of these two values is going to be 1 over 4 minus 1 over 7. Okay, so this is going to produce a positive value. Okay, so that means this is going to be let's see, 1 over 4 minus 1 over 7 is 7 minus 4 over 28. So that means it's going to be 3 over 28. Okay, I have two equations. I have 1 over f equals to 1 over u plus 1 over v, and then the second equation relates between radii and focal length. I will have 1 over f equals to the refractive index of the glass or the lens over the refractive index of the medium minus 1, and then 1 over r1 minus 1 over r2. Okay, in general, your converging meniscus lens is going to look something like this. It's going to look something like this, where they both have their r1 and r2 either both in front or both behind the lens. Okay, so then I can equate these two equations. I can have equation 1 equals to equation 2. Okay, I will have 1 over 24 centimeters, positive 24, because the information is given that the object is placed 24 centimeters in front of the lens. My u is going to be positive 24, and then plus 1 over v I don't know, in fact v is what I'm looking for, and then the refractive index of the glass is 1.52. It doesn't say where is it placed, so I'm going to assume that it's placed in air, right? So it's going to be n of medium is 1, and then of course I have my 3 over 28 as I've calculated just now. So then I am going to find that my image is in fact positioned at positive 71.186 centimeters. So this is my answer for the first part, which is to determine the position of the image. Okay, so if I were to know whether the image is magnified or diminished, I will have to look at the magnification of the system, of the whole thing, right? And this is just negative v over u, right? So my v is positive 71.186, my u is positive 24, and that leaves me with negative 2.97. Okay, 2.97. Okay, since the absolute value or the modulus of m is bigger than 1, I can say that my image is magnified. Okay, going to be magnified. That is my answer, and the calculation is my explanation, my justification. Okay, so let's move on to the next question. Okay, so now we are looking at the question from 2021. Okay, so 2021, let's read the question. And orange is placed 25 centimeters in front of a diverging lens with a focal length of 18 centimeters. So that means I have my U to be 25.2 centimeters, and is going to be positive. And then my focal length is, because it's diverging, therefore I know it's going to be negative 18, which is less than 0 because it's diverging. All right, because it is diverging. All right, so the first part is going to be sketch the ray diagram to show the formation of the image. So let me just do that right now. I have a diverging lens. The easiest one to assume is just that it's going to be a biconcave lens. Okay, a biconcave lens like so. And then I have my object 25 centimeters in front of the diverging lens. That means it's going to be beyond my f. So here is my f and here is my u. Okay, let me just make my biconcave lens a bit bigger. I will have something like that. Okay, and then the first line I'm going to draw is a line that is parallel. Let me just use yellow for that ray line. Okay, I have something like this, and then once it gets to the lens, it's going to be diverge. It's going to be moving away from the principal axis. Okay, so that is the incident and refracted ray. And then the second one I'm going to draw right through the middle. Okay, so in what direction is it? It's going to be in this direction. Okay, so now I can see that my image, let's just use blue, is going to be over here. Okay, the blue one is my image. Okay, so now I've done the first part, which is to sketch the ray diagram. I've done that. Now I want to determine the image distance. I can quite easily do that using the thin lens equation, which is 1 over f equals to 1 over u plus 1 over v. My f is negative 18. My u is 25.2 plus 1 over v, which means that my v is going to be equal to negative 10.5 centimeters. That is the answer for the first part, which is the image distance. Then now I want to look for magnification, and this is equal to negative v over u, which is negative v is negative 10.5 over u, which is 25.2, and this is going to give me a positive number. I can see it, right? Because negative and negative makes positive. I will have 0.42. Okay, so that is my answer for the second part, which is what is its magnification. Now I need to find out two more characteristics, or determine the two characteristics of the image. In fact, I will give you three. Okay, the first one being the modulus of m is less than 1, right? It's 0.42. If it's less than 1, it is going to be diminished, or it's going to be smaller than the object, right? Because m is bigger than 0, it is going to be upright, and because v is less than 0, that means it's going to be virtual. So your image is going to be diminished, upright, and virtual. Okay, all right, so let's look at the next question. Okay, so we are on the next question. Let's look at what we have. The convex meniscus lens has 17 centimeters radius for its convex surface, right, and 25 centimeters for its concave surface. So I can quite easily just say that my R1 is 17 and my R2 is going to be 25. Okay. Yep. Okay. So then, right, I can look at the next information that is given in the question, which is the lens is made of glass of refractive index of 1.52. That means I have n of the glass equal to 1.52 when the lens is in air. So that means my n medium is 1. Okay, and then determine the focal length of the lens. Quite easily I can use the lens maker equation. I can have 1 over f is equal to 1 over 1.52 over 1 minus 1, and then 1 over 17 minus 1 over 25. Okay, so once I have that, I can quite easily find that my f is in fact equal to, let me just key that into my calculator. I will find that it is equal to 102.16. So 102.16 centimeters. It's quite easy as that. Okay, now I just want to mention something about this convex meniscus. Right, in general your convex meniscus is going to be a converging lens. Right, convex meniscus is going to be converging. So in order for me to get a converging value, I must have, so let me write it down. This is for notes. So it's always good to have this kind of small notes as you study, right? So the note here is that a convex meniscus is generally going to be converging. Okay, and this would mean that my 1 over R1 minus 1 over R2 is going to be positive, right? And this is only achieved, so example given, this is going to be achieved by having 1 over 17 minus 1 over 25. Okay, what other ways that I can achieve this? I can also achieve this by having it the other way around, which means I will have 1 over 25, sorry, 1 over 25, that's correct. 1 over negative 25 minus 1 over negative 17. As long as they're both the same signs, they are going to be positive. If they're in opposite signs, that is a biconvex lens. Okay? Alright, hopefully that clears things out. And then we'll move on to the next question. Okay, so this is going to be the last question I'm going to discuss in this video. Let's just take a look at it. Alright, the figure shows a lens of radii curvature of 15 centimeters and 50 centimeters. Okay, and it's made out of glass. Now if we look at the diagram, okay, we can see the size at the middle here, let's just call that D1, is smaller than D2. Okay, so D1 is smaller than D2. This would indicate that this type of meniscus, right, this type of meniscus is a concave meniscus. Concave meniscus, and this is a diverging meniscus. If it's a diverging meniscus, that means my f is going to be less than 0 or negative, right? And I can achieve this by having 1 over R1 minus 1 over R2 less than 0. How do I make this happen? Well, one of it is that I can have the first one being 1 over 50 minus 1 over 15. Okay, so if I have this, I will have it less than 0, or I can also have the other way around, which is minus 15, and then I have at the back minus 1 over minus 50. This will give me less than 0 as well. Okay, so either one's fine, either one is okay for you to use because they're both the same. In fact, let us just calculate that right now. I have 1 over 50 minus 1 over 15. Okay, that means I will have 15 minus 50 over 50 times 15 times 15. I have 750. This is going to be equal to and I would like to simplify this actually. So if I have 15 over 50, 15 minus 50 over 750, I will have a value of negative 7 over 150. Negative 7 over 150. Okay, I need to look for the focal length. I will have 1 over f equal to the refractive index of the lens over the refractive index of the medium minus 1, and then 1 over r1 minus 1 over r2. Okay, so 1 over f equals to 1.55 over 1 minus 1, and then I have negative 7 over 150. Okay, so if I were to key that into the calculator, which we can do right now, right, 1 over f and then 0.55 times 7 over 150, I will have a focal point or focal length of 38.96 centimeters. So my f is going to be negative 38.96 centimeters. Okay, so the focal length is negative 38.96 centimeters, and the type of lens is a diverging lens or diverging meniscus lens. Okay, so diverging and 38.96 centimeters. Okay, all right, that is all from me in this video. Thank you very much.